We are live back, but the issue which happened earlier was that you guys suggested that the stream would go, but what happened was that the stream actually went away. So really apologies. Actually, we'll just quickly go through everything again. Now I switched it back. Everyone, whosoever was there, I'm really sorry. What happened? Who 4 guys are right now? Just comment. Whosoever is right now here, I'm really sorry. Like, you guys suggested that we should actually end the stream. I ended the stream. Sorry, I actually stopped the stream. Stop stream option was in OBS, not in YouTube. I stopped it. It just got stopped, but nothing I could change. I ended the stream. It just ended entirely, and now I could not restart that. But no worries. We will just start back with the questions again. A few folks, whosoever is there, just quickly mention that no problem, you are helping us. Ashish Pal is back here, and who all folks are just back, just write down hi, hello. Saurabh is back here, and Anirudh is back. Cool. Ajay Kumar, hi, I am here. Yeah, sure. Now, before further ado, we had reached 15 likes, but no worries. Aniket, no worries. We had 15 likes, but yeah, for sure, you guys will for sure bring that to those likes. But no worries. Let's quickly jump back to the problems. We discussed the first problem itself. Just quickly going through over it. It was very simple. It was just that I had to give the distance difference in which I had to compute the suffix minus prefix of a subarray. So basically what I did was that for at any index I just computed the number of distinct element in prefix, number of distinct element in suffix, and then subtracted that to find the number of distinct elements in any particular thing. Let's say to find from 0 to I, number of distinct elements are there. I can use anything, a set, an array, a map, an unordered map, an unordered set. I can use anything. So basically in this video we used a set. Let me quickly just go through the code itself, although we discussed that same thing, but still that was very bad of us. So basically what we did here was, oh god, it's again saying that it is okay, so that was not an issue. So yeah, now we are back. So just again think that we have this whole set, then we just, I know that YouTube is saying that it is not receiving enough video to maintain the smooth streaming, but not sure. My internet is pretty good. Not sure what's happening right now, but yeah, we'll still continue with the stream right now. No matter what, we're not gonna stop anything anyhow. Cool. So basically, firstly, we inserted those elements of prefix. It is just to count. Okay, as we go on to an index, my prefix is being increased one by one. Then I just went on to find number of unique elements in my suffix, which is from which means from I plus 1 to n minus 1. I just went on and inserted in my set. Mark my words, you can use anything whatsoever, set, unordered set, map, unordered map, an array also. Just that because constraints are very small. So no worries about anything. Then I just did, okay, it is the prefix size, it is the suffix size, and I just get the answer. That is how I did my first question. Now moving on to the next question, because as for sure we had discussed first question itself. Now the second question, no worries, let's go on. So basically as we go on to second question, before that, can we quickly reach to 20 likes, because viewers are 22? Please, if that would be great, if you can just help out to just increase those numbers. And before that, please, whosoever is there, just mention how many problems you were able to solve and which one you thought was trickiest. Let's say you were able to solve 1, 2 and 3. So out of those 1, 2 and 3, which one was the trickiest and why you were not able to solve the one problem which was there, let's say 4th or 5th, any one. Now moving on to this question, which is frequency tracker. It just says that we have to design a data structure that keeps a track of values in it and answers some queries regarding their frequency, which means we have to design a data structure. It can be anything. Like the standard ones we have are arrays, maps, unordered maps, sets, unordered sets, and all these stuffs. What we want is to design a new data structure which will, what it will do is it will keep track of the values in it whatsoever values I'm going to give him, it will keep track of that, and also some queries regarding their frequencies. Cool, no worries. Implement the frequency tracker class. It is one thing. What the function will perform by this class are frequency tracker. It is one constructor which will actually initialize the frequency tracker object with an empty array initially. So basically, the main task of this constructor is to initialize an empty array. Empty array as in, okay, I can have this empty array. Now, what will happen in this particular function is void add. Add what? Add a number. It will just add a number to the data structure. Let's say I have some XYZ data structure. Let's name it as X. Now, an element called as a number, let's say number, is added in my this particular data structure, which was an array. So basically in this array, this number got added. Cool. Now void delete int number. Delete one occurrences of number from the data structure, which means what if I had added this number again and again, which means I added, let's say this number, let's say n1. I added this number in my data structure one time. Cool. I added it again n1. I added again n1. I added again n1. Let's say I added another number n2, then n3, then n1, then n2, and so on and so forth. Now comes the option. Here I was just adding. Let's say now comes the operation of delete. Let's say it just says me now, okay, delete one of that number. Let's say it just says delete one, n1. Delete one occurrence of the number from the data structure, which means I will just delete one occurrence. I will just delete one occurrence of n1 from this. Just one occurrence. If it would have asked me to delete n3, I would have deleted, okay, n3 is there, I will just delete it. Now it says that the data structure may not contain the number, and in that case delete nothing. Let's say if I would have asked him again, oh, go and delete n3, so it would have just want and it would have tried to delete n3, but n3 was not here, so I would have not deleted it as such. Cool, no worries at all. Now next thing is says, okay, bool has frequency, which we have to return something. Bool has frequency returns true if there is a number in the data structure that occurs frequency number of times, otherwise it returns false. Now out of this whole thing which I have maintained, initially it is named as array, but I can take anything, but it just says I will give you a frequency. I will give you a frequency as 3. You have to return, is there any number which occurs 3 times? I will just check. n1 occurs 3 times. No, it occurs 4 times. Oh, sorry, I can't return n1. n2, it is 1 time. It's also not 3. And I only have n1 and n2. So, sorry, really apologies. I cannot have anyone which occurs 3 times, exactly 3 times. That's the reason I'll just return a false. While if it is the case that, okay, I would just have said, okay, return me if there is number which has frequency as 4. I would have went into my particular data structure and asked him, is there anyone who has the frequency as 4? It would have said, yes, I have 4. Cool, no worries. I can return a true because I have found an element with a frequency as 4. Before that, if you guys are enjoying it, then no, without even a single thought, just smash that like button. Let's reach to 20 likes. That was pretty easy. One more. Now, you know what you have to do. You have to just get all these 4 functions done. One thing is initialization, in which maybe you will choose any combination of data structures to actually solve your problem, or maybe a single data structure also, depending on the question. Now the operation, one operation was to add, another operation was to delete. I have to do only these 2 operations. The last thing which I need to return off is by this. It will just ask me has frequency. I have to return something from here, which means if there is some number having frequency called as this frequency, or if it is not. Cool, no worries. Let's see the example pretty quickly. Firstly, we have this initialization. Cool. Then I added an element. I added 3 in my data structure. Then I again added a 3 in my data structure. Then I asked hey, you have any element with the frequency as 2. I will say yes, I have an element with the frequency as 2, which is 3. So ultimately I don't want the number. I want, okay, is there an element with a frequency as 2 or not? And it is. I have an element with a frequency as 2. So no worries, just give it the true. That's pretty much it. Let's see the next example pretty quickly. The interesting thing I noticed just right now is the likes were 21, but it just reduced back to 20. I don't know how. The people are saying, okay, when Aryan will say only then we will like, else we will not. If it is the case, then for sure, reach that to 25. I will be happy as AF. But yeah, no worries. It just says, okay, add an element in our data structure. I added 1. Then it just says, delete 1. I had only one occurrence of 1. Okay, I will just delete it. Cool, it has gone. Hash frequency. Is there any element with the frequency as 1? I see my data structure is empty. I have no element with the frequency as 1. No worries, I will return a false. Now, you got to know ultimately what you have to do. What you will do is, let's forget for now what are the constraints. But ultimately, remember what you have to do. You have to just add an elements. Let's say I add x1. Then I added x2, then I added x3, then I added x2, then I added x4, then I added x2 again, then x1 again, then x1 again, and so on and so forth. I will just keep on adding the elements. Next operation was to actually delete the elements. Okay, cool. I will just delete my, let's say, x1. I'll delete. Let me change the color and delete that. I will just delete that x1. I'll delete the x2. If it is present, I will delete the x3. If it is again asked to delete x3, I will not delete x3 because x3 is finished. Cool. So x3 will not be deleted if it is finished, right? Last operation was to actually check, okay, the frequency of these numbers. Frequency, I will just be having, okay, is there any number with the frequency, let's say as n? Is there any number with the frequency as n? For that, one thing I need to make sure, to maintain the count of every number, which means x1 occurs how many number of times? 1, 2 times. X2 occurs number of times? 1, 2 times. X4 occurs how many times? 1 time. And that's it. Now I will just go and ask him, hey, is there any number which occurs n times? N is it is asking me as a query, is it a number which occurs n times? I will just say, oh yeah, it occurs n times. So one thing you for sure got to know, one thing right now, that you need to maintain the frequency of every number. One hint you get to know, because ultimately you just need to check, okay, is there a number with the frequency as n? For that you need to maintain, okay, right now, because it is very standard that you will not go on in trading, okay, let's go on and check right now what is the frequency of every number. You can, because see, operation is just adding and subtracting. If you by anyhow use an unordered map, then for x1, let's say it is an element is added, I will just add 1 in my unordered map. If the element is deleted, I will just subtract 1 from my unordered map. But here is a star, here is a caveat, then I will delete only when it already has some element, which means your unordered map of x1 should be more than 0, then only I will just delete it. So one thing I get to know, okay, by using this unordered map, I can perform my addition and deletion function very fast. But what I am concerned about is to find the n, frequency of number, which means the output of my unordered map. I have to iterate on the output of my unordered map to find, okay, is there an element with the frequency as 2 as n? Let's say n is right now, let's say 3. So I will just go on in my unordered map completely to find out, okay, is there any number with the frequency as 3? If there is not, I will just return and okay, no, because in an unordered map, the key is the value, the key is the element number itself, and the value for that key. See, in an unordered map, the key is the number, the value is the frequency. So basically, now let's see the constraints. Is it that we can do this? Let's see. I have the number of numbers. It can be 1e5. Cool. The frequency, it can also be 1e5. At most, these number of calls will be made to add, delete, and has frequency, which means I can just add 1e5 numbers. But as I saw, okay, I can just add a number in O of 1 time. So it is just very easy for me. O of n operations will go, and I will be good to go. I can subtract a number from my data structure in O of 1 time, and I will be good to go. But my frequency will be number of calls as 1e5 calls. But to find if this frequency as n exists in my entire data structure, I had to iterate on my entire data structure for every of those frequency. And this entire, it can be x1, x2, x3, and numbers, it can be 1e5 also. So for this one frequency, to check, okay, is this one frequency n? Is there anything like that? Any number which has frequency as n, it exists in my data structure or not? I have to iterate on my entire array, entire data structure, which will be O of n itself for this one frequency, and this frequency itself can be around 1e5. So 1e5 into 1e5, that will give a 1e10. That is, you can't do it. So up till so far, you were super fool. You were super cool. Sorry, not super fool, but you were super cool. That what you were doing was that, okay, to add an element, you just use an unordered map to add that element. Okay, right now I encountered 1 for x1. Right now my example says add x1, so I just added x1, which means increase the frequency of x1 by 1. If my function says delete x1, I will just go and ask and see, hey, is the frequency of x1 so far, which means unordered map of x1, if it is more than 0, which means, okay, x1 is at least present with me so far. If it is the case, I will just unordered map of x1, minus equal to 1, which means I will just delete the frequency of x1 by 1, because I have the operation of deleting x1 by just one operation. With this, I was able to perform my add and my delete operation in O of 1. But the only issue which we encountered so far was having this frequency thing, which means I need to return, is there a number with a frequency as n or not? So the issue what we encountered was, why it was an issue? It was an issue because we can only iterate on keys, and the value we can't iterate on, because I can just go and point, okay, what is the frequency of x4? It will return me 1. So x4 I can query right now, okay, x4, x2, x1, but I can't query these two on the right side because all these are the values, not keys. Keys are on the left side. How about I just reverse the entire thing? Which means let me make these as keys and these as values. That would be interesting, no? Which means what I will do is, firstly, although I need to maintain an unordered map because I need to add and do a delete operation, so I need to maintain that unordered map. But as we saw, we can only iterate on keys because I can just query a key right now in O of 1 time. So how about I just make these frequencies as keys itself and these numbers as the values itself, which means this 2, this 2, it can have some numbers. It is the frequency right now, and it is the actual numbers which have these frequencies, because I wanted this frequency as the key because I am querying on the frequency. So I just want, okay, I should get the frequencies in very less time. So I just get this frequency 2, but now it is not one number. It is x1 and x2 both, and I can't have duplicate keys, so I need to push in x2. For this, in the frequency 2, the elements in my number, it can be x1, x2, and so on, so forth. For this frequency as 1, element can be x4. Now you will say, as soon as the query asks me, hey Aryan, is there any number with the frequency as 2? I will just go and check. Okay, frequency as 2. It is storing something. I will just ask you later, what should be this data structure? What should be this data structure? Just write down below right now. For this map of frequency to this numbers, how will you store this numbers? In a vector, I am giving you option, in a vector, in a set, in an unordered set, or in another map, or in another unordered map, or something else, nota, NA. I am just asking you, while you make this new map of from frequency to the numbers, then what frequency, for sure you will just choose another map of frequency to those numbers. Frequency is just one number, so it can be int to what, just comment down below right now what it can have. Anirudh says array list. Okay, Anirudh says array list. Others, just write down below what this number can have. But before that, if you guys have not liked it, just smash that baby. It's your baby, right? And you like to spank and smash your baby, right? Just spank that and let's reach to 30 likes. But before that, array list, why can't use contains value in the first map itself, which stores numbers to frequencies, map of int to array list. Okay, why can't we use contains value in the first map itself? First map, okay, contains value. What is the complexity of contains value? Set, Shalini Jaha, set. Okay, for the folks who said array list, you remember one thing. Is it that, okay, let's see. For 404 not found, can you just please elaborate what's the complexity of contains value? I'm not sure of that, the complexity of that thing. I had done this question by using hash map and array. Yeah, it can be done in multiple ways, but just a quick thing that you to actually store this numbers x1, x2, and let's say you have so many numbers so far. Let's say right now it is having x3 and x5. Now let's say I did a operation such as I just asked you, okay, you know everyone has a frequency as 2. I just again asked you, firstly I just asked you a query, hey, is there a number with the frequency as 2? Now you just went, okay, frequency as 2, it has something in this. I will just check, okay, it has a particular size more than 0, which means it has something. I'll return a true. But next, let's say I just asked you for a query. Hey, delete x2, which means what you have to do at runtime only is you have to remove that x2 from here because its frequency is no more 2. Its frequencies has reduced to 1. Now in 1 you have to add x2. Let's say I again asked you delete x2. You have to again delete that x2 from here, and now it has just gone away because I don't care about if anything has a frequency as 0. Now let's say I again asked you, hey, just add x2. Now you will again have to add that x2 again here. I just again asked you, hey, add x4. So you have to remove the x4 from here because its frequency has increased from 1 to 2 and add that x4 to basically here. You remember what will happen at runtime? For this frequency thing, you will have to find, because see, as and when you do the add operation to any number, its frequency will change, which means its key will actually change. So it has to be removed from its original key, and now the new key which is made for him, it has to go there. That is the reason we have to use a map of int and set, some hashing and arrays. So yeah, you can just use multiple hash functions, basically hash maps, to actually map, okay, how's the frequency of number is changing. But it is one thing which comes very fast. Okay, we have the number, we have the frequency, but as we know, we can just maintain the frequencies, add and subtract, add and delete operation by using this simple map map 1, let's say. To actually check the frequency as key, I can just go and see as these numbers and just check. Okay, I just go and query, is there a number with the frequency as 2? I will just go at the frequency as 2 and check, is that data structure size, which is right now a set, or you can also use an unordered set, is that having any size or not? If yes, then I can just say, okay, I have got. And as soon as I do any add or delete operation, I have to remove that element from here and actually put that element into a new, let's say if the frequency has again increased, so the frequency has now become 3, so that x4 will actually go here. Thus, I have to remove that element in very less time and add an element in very less time. That's the reason I have to use a set in here. So that was all. Let's see how to actually code it. It's also pretty easy to code. Just a bit thing was only in the thinking part. Let's see that yes, we are full. Sorry, what I'm reading. One for second TLE. I think 2 was the trickiest. Yeah, 2 was actually trickiest. MN90, you MN90. Third question, the third was trickiest. Third question was what? Third question was not tricky, I should say. Let's just quickly reach. Before that, let's reach on to 30 likes. Just meanwhile, we will actually reach to the problem itself. But yeah, first let's go through the problem itself, that how we will code it. Then we will actually go on to the comments, what you guys are saying. Firstly, I have this map which I showed you. Actually will contain, okay, it is the frequency. It is for this int, it is frequency to actually what all numbers have that frequency right now. It is my main map, which is the next map. And one map is to contain, okay, what is the current frequency of every number right now? It is the number itself and it is the frequency of that number, right? The next int. It is to have that, okay, from number to its frequency, it is the frequency map, and the above map is from frequency to the set of numbers. Now I have to initialize my constructor. I can initialize by just clearing this constructor because I have globally initialized my both the data structures required. Add a number. Now add operation, adding a number, which means first make sure your main task was, let me show you. Firstly, screen should be visible. Yeah, it is visible. But let me quickly show you our main task. Your main task while adding a number, your main task is that firstly you have to grab, because see existing, let's say you are saying add number x2, which means x2 maybe right now it is there or it is not there. So basically let's say it is frequency and it is the set of numbers, right? Now the frequency is 2 and those numbers are, let's say, x2, x4, x5, and frequency as 3 is, let's say, of x1 and x6. Right, now I'm saying add x2. So basically what you have to do is, firstly you have to find, okay, what is the existing frequency of x2. It will be found out by the standard frequency function which you have made a standard map, in which you will just pass x2 and it will return you the frequency of x2. Right, it will just give you the frequency. By this frequency, you know, the frequency of this x2 is 2 right now. Frequency is 2. You will just go on to your next map, which is MP, which is actually containing frequency to the set of numbers. You will just go and say, hey, from this map for frequency 2, remove x2, because x2 is about to be added, so its frequency will increase. So basically remove from frequency 2, remove x2, and as its new frequency will become 3 because it is being added. So just in 3, go and add an x2. It is the operation we have to perform while we add an element, which means find its existing frequency, remove that element from the existing frequency, increase its frequency, add that increased frequency, in that increased frequency number add that element. It is these operation I have to perform. Let's quickly see how it will look like. So basically I will just find the existing frequency, which is the previous frequency. P frequency is the previous frequency I will find for this number. If this is not a 0, which means it may be happen that, okay, I'm adding this number for the first time. If it is not 0, I will just erase that number from my MP map, which is having frequency to the numbers whole set. I will just erase that number from that. Then I will just, as I'm adding that, so I will just add the frequency of that. Now what I will do is, the new frequency for me is this new frequency after being added. So it is the new frequency, right? I will just insert in that new frequency map, I will just insert that number, because now its new location is its new frequency. And it is the same operation I will do for the delete function, which means firstly I will just find its previous frequency, what its existing frequency was before being deleted. Then I will just check, okay, if the previous frequency was 0, so don't delete it, just return, because if it's already not existing, why should you delete it? You should not. Cool, no worries, just don't do that operation of delete and just return. But if it is there, if it had been there, just reduce, just firstly from the existing frequency called as pref frequency, remove that element, which is erase that element, decrease its frequency, because you are ultimately having operation of delete, and then again find its new frequency, which is nothing but you have just reduced the frequency, so the new frequency is nothing but this frequency number, and then ultimately add in your map for that new frequency, insert this number, because it is ultimately what you are doing. And it is both same, add and delete are more or less same operations, exactly same operations. And ultimately has frequency will just go and check our map and we'll see, hey, this map of frequency will return these set of numbers, and I will just check, is this set of numbers is having something? If it is yes, if the size is something, it should be something. If it is yes, I will return a true, else I will return a false. And that is how you will solve this problem. I hope that you guys liked it. If yes, then do smash the like button. Let's reach to 35 likes. Spank it like your baby. Very cute baby. Like as when you are happy, you like to spank, smash, do whatever you want. But yeah, let's quickly go on to the comments very quickly. That no problem, you are helping us, no problem, we are also back, don't worry. Cool. Hi, I am here. Yo Koini bro, yo, we are back. Ritesh Goyal, Shalini Jia back. I was not able to solve the problem 4. I was thinking about you only, he will teach me. Cool, no worries, we'll see. Jai Shri Ram, only 1 year. 1 year for what? Ritesh, 1 year for what? Sorry, I just missed that. 3 questions and 3 was the trickiest. I think 2 was the trickiest, 3 was actually kind of a normal, but yeah, it may be. Depending upon how we approach a problem, it may be tricky or may not be tricky, but let's see. ML90, I was thinking 2 was the trickiest. Yeah, 2 was the trickiest. 1 for second TLE. Cool, no worries. Solve third. 2 was tricky. Yeah, 2 was, and that we saw. I was able to solve the 2 with 4 penalties. 4 penalties, no worries. Solved 3 questions, got TLE so many times in number 3. Still, no, the solution was not good. How, Shalini? TLE in the third. Let's see. We will see the third question. Bhai, aisa mat karo. From where I can get the question list? Yes, we are full. What about contains value of map? Array list. Why can't we, like we saw that, why can't we have array list? And set, I have done this question by using hash map and array. It can be done by hash map and array. No worries. Why can't we use 2 hash maps? One for num to frequency, and another for frequency to frequency. Frequency to frequency. Yeah, we can also use that. We can use from frequency to frequency, which means frequency of numbers to actually number of numbers, such that we can just increase that frequency. So basically the same problem can be done by 2 unordered maps also. So who was this? Shivam Garg was some Aniket and Shivam Garg. I used 1 to 2 maps for frequency. Yeah, Shivam, Aniket Singh and Shivam Garg both are correct. Ashish Pal, same hash map and array. Ashish Pal, map of int and set. Chef, I think there is no point in storing the numbers of a particular frequency, rather than we can just store the frequency of frequency. Yeah, correct. That is also true. We can also store the frequency of frequency, because it's just that we are just concerned about is there any number or not, and we can just get that in much less time also, because it's just log an operation to actually insert and delete an element from that set. While if you use a frequency of frequency, that would be much easier, but not sure of how easy for other people might it to be imagined, but yeah, the same thing, because the set is actually containing those elements, and you can just contain, okay, the frequency of right now I have 5 elements. If let's say x2 is being removed from here, so basically 5 will reduce to 4. It is going to, let's say, frequency of 3. So basically here at frequency 3 we had, okay, let me change. Here for the frequency 3 I had these, let's say, 4 elements. X2 was going from 2 to 3 frequency, so basically its frequency will increase. So yeah, you guys are correct. For yeah, it's O of n for contains value as well. O of n for one operation or for all operations. Aniket, cool, got really in this. ये logic click नहीं किया. No worries. Ram sir ji, Ram, how to build an intuition for the problems like you? It's just that you have to go on. They see, as I speak, I just show on the intuition at how I thought it should be. Initially, I thought, okay, it should have a frequency. It should have an unordered map of frequencies to the numbers. Then we went on to actually figure out that maybe that frequency part might not be that convenient, because we need to actually query on the frequency itself. So we need to have another thing that's unordered map from that frequency number to something. Now we need to actually remove an element and add an element again and again. So we thought, okay, maybe we can use a set. That is how I used. But as I see also, people have just used, okay, the count of numbers is what is concerning to me. So I will just decrease that count and increase that count. It is how others think. So it is how we all think that, okay, it is not working for us. Let's think of something extra. It is not working for us. Let's think of something extra. That is how we actually approach a problem. Okay, how to build intuition for the problems like you are the best. Not cool, no worries, Ashishpal, thank you. Chart revision going on by Aryan. Cool. For all it takes O of n. Cool, then maybe for all it takes O of n, which means for all the queries, because the frequency it can hit O of n times also. So for all O of n times, if dot contains value, will actually give you, it's very hard to actually say if dot contains value will actually query everything for every query, which means for every query it should give me answer in O of 1. It is done by keys, but yeah, that may be possible. If that's the case, if dot contains value can give me a query result in O of 1 for one query hit, if I just hit and find, okay, dot contains value, if it can be done in O of 1, then it's good. It will 10 minutes contest, if yes, and how many times you have completed and how many questions. So basically like I did a blunder on 4th one, very big. Yeah, for sure, if it is giving TLE for you, then for sure it might happen that for one query, for one frequency number, you are finding in O of n time, but you have to find for one frequency in O of 1 time. That is the case. So basically, like for this first 3 problems, it was just under 25-30 minutes, not sure. And for the last one, I did a big blunder. I will show you that what I thought, and ultimately it was very easy. I was thinking of TP on trees and whatnot for that last problem, but yeah, that was very easy. But yeah, let's quickly move on to the problem C. That was actually easy one. Let's quickly shift to our tablet, and here we go. But before that, you guys, you just stop reacting to that like button. Just smash it very hard, not hard, such that your cute phone is safe. Just that, okay, it is safe and cool, chill. Now let's move on to the next problem, which is problem C. Number of adjacent elements with the same color. So basically it just says that there's a unit integer array called as nums of length n. Initially all the elements are uncolored, has a value 0. Cool. Nums has initially all the values as 0. It is one thing. Just write down what you see, what you hear. You are given a 2D integer array called as queries, where queries of I is nothing but index and a color. Index is 0, 1, 2, 3, 4, and so on and so forth. Index, it will just say, okay, the query is at this particular index, mark this color right now. Cool, no worries. For each query, your color of the index I, for this query I, index I with the color I in the array. So basically what will happen is, for this query I will just go at this index I and will color this index I with the color of I. That is what I have to do at every query. Cool. Return an array called as answers of the same length as queries, which means I have to find the answer for every query. What is the answer like? We will see. But what we have to do is, where the answer of I is the number of adjacent elements with the same color after the ith query, which means after performing the ith query, right now how many number of such pairs are there, that number of adjacent elements are of the same color. Which means, let's say if at one query I made this index 1 as 2, color 2, next query I made this index as 2. So at this query right now I can just say, hey, I have one adjacent elements having the same color. Okay, for this query the answer will be 1. So I have to perform this operation after every query. Cool, no worries. More formally, answer of I is the number of indices j, which means I have to, for every query I have to go into the entire array such that 2 adjacent elements have the same color. And for sure it should not be 0, because initially it was 0. So don't count it is of the same color. Nah, it is not the same color. It was initially 0. So 0 is not what I count. Color is what when I paint it, then it is called a colored. You got some things, but if you have not, let's see with example that what you have found. Initially, I will just say, I have my array, all the values are 0. All as in how many? How many as in 4 values. So 0, 0, 0, 0, 0, 1, 2, 3. These 4 values are 0. Initially, it is my array. Now, what will happen? At this first query, okay, the color is pretty big. That's what she said. No. So basically what happens is that at the 0th index, I will just color it with 2. So I just colored it with 2. Cool. Now I will just query. How many number of adjacent pairs are there such that they both have the same color? Same color? Nah. Same color. I can't count 0. No worries. I can't count 0. No worries. So number of such adjacent pairs are actually 0. 0. Answer. For this query, I am done. Next query. Okay, first query is done. Next query. At index 1, put the color as 2. Next one, put the color as 2. Okay, cool, no worries. I will just go and count. Hey, I have found one adjacent pair. Yeah, it is colored, same colored. Okay, one I have found. I will just go and next. It is same color. No, it is same color. No worries, because it's already a 0. So yeah, it's just one pair I found. One pair I found. One pair I found. Okay, it is done. Next query. Color query 3, the color index 3 with 1. I colored it with 1. I will just go and found one pair. No worries. So right now, still the number of such good adjacent pairs are nothing but 1. Still it is 1. You will see it is 1. Okay, cool. This query is done. Next query. Color index 1 with 1. Index 1 with 1. No adjacent colored which are same. So answer is 0. For this query, answer is 0. Cool. Let's go on to the next query, which is 2, 1. Color 2 index with 1. Same color. One pair. Same color. Another pair. In total 2 pairs. I'll just get this. So basically you saw what's happening. What's happening is, for every query, I am just modifying the value, particular value. Initially, you will see it was all 0, 0, 0. And I was just modifying a value. Let's say I modified it with 2. Now what will happen is, I will just go on this entire array and check. What is I can do? What is number of such good pairs, good adjacent pairs, how many are there? I will just go and count. Now you will ask, Aryan, looks easy. Can we do simple what you told? Like we will just go on to every query, modify its color in the array, because array you are making right now. So we can also make an array and we can update any index of an array of one time. We will do that. And ultimately what we will do, we will just for this answer of that query, because query is just modifying, but result also need to be put in the answer array. For answer of that query, I'll just go on this entire array itself again and we'll just find what is the number of adjacent pair which are actually good. Firstly, just write down below how will you solve this problem. For those who just think right now by just seeing this, how will you solve this? And for those, let's see if we can solve it by this or not. If we just see, n is nothing but 1e5, which means the length of this is itself 1e5, right? Number of queries are also 1e5. So for one query, I am going to iterate on this entire array. Another query, I am also going to iterate on this entire array, which means for every query, I am going to iterate on this entire array. Is it what I am going to do? It will be 1e5 into 1e5. That will be 1e10. That you can't do. But you also know one thing for sure. You have to iterate on every query no matter what. No matter what, you have to iterate on every query because you have to find the answer for every query. That is one thing you for sure know right now. Is it? You know or not? Right? Firstly, before you guys, let's reach on to 40 likes. Just two more likes. Shishank. Simple arrows here and check. Correct. That is one thing Shishank wrote right. Let's see how. So what we saw is that we have to go on to every query. But the issue for us was that as we go on to every query, we have to find the answer in maybe O of 1 or O of log n. It is what maximum I can do. Which means for every query, I need to find the number of such pairs. I can't go on the entire array. I can't go. I have to find it in O of 1 or O of log n. Let's see how we will do it. Which means I will initially, let's say I was at this particular number. I just updated it. Now I want to find initially, let's say initially so far I know what is the answer so far. Let's say initially it was all zeros. I added a 2, added next 0. I will just say initially it was entirely 0. No impact. So as soon as it is added, when an element is added, how it can impact others? If I am added, how will I impact others? I can only impact my adjacent ones. Why only adjacent ones? Because my answer is only impacted if the adjacent elements are of the same color. So it might happen that at a particular point of time, I have the colors like 2, 3, 2, 2, 3, 3. So as soon as I change this color, so basically you see 3, 3, which was actually already a pair, it will no more be a pair. If I just add a 2 here, which was earlier 3, 3, 3, 2, it was never a pair. But because of this addition of 2 in the place of 3, it just became a pair. So basically addition of an element, it can only impact its adjacent ones. That's it. Which means addition of 2 right here, as the left is for sure nothing. So it can only impact its adjacent ones, which means right side. It will only impact its right side. Right side itself already 0, so it won't make a pair. So query, which means answer, which means adjacent pair right now is initially 0. Cool, it is done. As soon as the next element is added, 1, 2, I will just update this 2. Now, because of this updation, what can happen is this thing, which means earlier it was 0. Firstly, I will check, okay, is there anything which this particular person was contributing to me? Firstly, because before replacing, I need to make sure now it was contributing something to me. Here we saw, if I just replace this 3 with 2, earlier it was contributing 1 pair. So firstly, I have to make sure, okay, I will ask, hey, are you contributing anything? So he will just go and check, am I contributing anything? Nah, because 0 we don't count. Am I contributing anything? Nah, I'm not contributing anything. So basically, I'm not contributing anything. So your answer will remain intact. It will not reduce right now. As soon as I replace some element, I will again check, am I contributing anything? I will check, am I contributing anything? I'm not contributing. Again check, I'm contributing anything? Yeah, I'm contributing. That's the reason I will just add a 1 because I'm contributing anything. So now, right now, the number of such adjacent pairs are nothing but 1. Cool. Now I will just add another at the index 3. I will just add another element called as 1. Thus again, it will just go and check. Earlier, firstly, before adding, was it contributing anything? So no worries, no doubts, no things, no wonders at all. Now, I added a 1. Is it now contributing anything? Again, it's not contributing anything. So no worries. It will just remain as it is. Cool. No worries. Answer will still answer is still this thing, adjacent result, which is nothing but 1. Now, as soon as the next element 1, 1 is added, before reducing, I will ask him, hey bro, at next one, are you contributing anything? He will just say, no, not from right, from left. Yeah, I'm contributing 1 from left. But sorry bro, I'm going to replace you with something else. So right now I have to remove your 1 contribution. So I will just remove your 1 contribution. I will just replace it by 1. Now I will check. Now I am being replaced. Now I will check. Am I contributing something new to you? Am I? Am I? For sure. Sorry bro, your answer is right now 0. Now again, as I add another element, 2, 1, 2, 1. Firstly, before replacing, I will just ask you, hey bro, are you contributing anything? I'm contributing anything? Nah. I'm contributing anything? Nah. I will just add right now 1. Hey bro, are you contributing now anything? He will say, yes, I'm contributing 1 from right, 1 from left. Yeah, 2 plus 2. Thus you will say, at every step, I can just maintain 1 variable. Let's say answer or adjacent colors, etc. Anything, just 1 variable, and keep on adding. If that upcoming element is contributing anything, and the removing element was it impacting anything or not. By this just one operation, for every query, I can just go on to this entire array. For this every query, I will just go on to that particular index only, and we'll just check. Before replacing that element, what was its contribution? After replacing that element, what is its contribution? I will just add and subtract those values. I hope that you guys got why I was only, as I am changing my element right here, I was only impacting my adjacent elements. That's it. No other element was being impacted, so I don't have to worry about other elements at all. That is what you have to do in this problem. So yeah, I hope that you guys got it. Before that, let's reach to 40 likes, just 1 more like, and we would be good to go. But yeah, before that, let's quickly jump on to, we will go into the comments after this, but let's quickly jump on to the code part. It's actually pretty easy. Just that we have to just remove the contribution. As soon as I add an element, just add the contribution. I hope the screen is visible. Yeah, it is. Make simple array, check on the go. Thanks, bro. Smiley. One key thing which really lead me to the solution was that answer can differ marks by 2 while going from query to query. Yeah, that is correct. Because simply it can just be impacted by just 2 neighboring neighbors. So it can just reduce the number by 2 or increase the number drastically by 2. That is all. Yeah, that was easy. I could have solved it. I wasted my time in question 2. Yeah, question 2 was a bit tricky than question 3 what I thought. But yeah, cool, no worries. But still, we will see this problem. The code is pretty simple. Firstly, I have this NQ, which basically says what is the size of this queue, because ultimately I have to make an answer array, because for this query, every query I have to give an answer. So basically this answer array will be of the size of this query itself. Thus, and as we can easily see that if n equal to 1, which means I have only 1 element, no matter how many operations I do, no matter how many queries I do, no matter how many queries are there, 1 element, it can just be 1. It can't have another adjacent element, because for adjacent you need to have 2 elements. So it's a base case that if n equal to 1, just return the answer as all zeros, because for every query the answer will be 0. Thus, if n equal to 1, return the answer as 0. Now what will happen is it will just go on, and as I said, I will just make that array ARR, in which at every what's happening? In which at every index, I'm going to modify that value at index I. Cool, that is for this ARR. Now it is the variable called as adjacent. I just show you. It is the total colored adjacent elements, right? Number of total colors. It is right now 0, because initially number of colored pairs, total colored pairs are actually 0. I go on to every query. For every query, I will just check, okay, what is the index it gonna impact and what color it will actually go and mark that index as color. It is 2 things. I will just go and check. For that index, what is the color it gonna impact on? And as I said that for I equal to 0, I can't compare left, so I only have to compare right. For I equal to n minus 1, I can only compare left, I can't compare right because I have nothing at right. Else for the mid elements, I can compare both left and right. Cool. Let's see for I equal to 0. It's nothing but I will only compare with the right. Right, which means firstly I will check. Hey, what before replacing, hey, what was the previous contribution? Previous contribution, I will ask him. Hey, was your value and your right value, because I can't go left for the index 0. Here the index is 0. I can't go left. So I'll only check for the right. Hey, your value and your right value, were they 0? Were they same? Yeah, if it is same, it will come as 1. If it is not, it will come as 0. If anyhow, whatsoever value it comes, if I to make sure that it should not initially be 0, right? Because as I said, 0, 0 values are same, but it is not colored right now, right? So I need to make sure, okay, it should be colored. If it is not a 0, which means it was colored and had the value as same. If it is, then I'll just update the value of total colored, which means as this ID is going to replace by the new color, so its previous contribution, which can be 1 or 0, it's going to reduce. Minus equal to that previous val, which means its earlier contribution, it's gonna reduce, right? You can also have a minus 1, but for that you have to add a condition that p val. So I just added, okay, it can be 1 or 0, so you can just reduce its contribution. Now add that new color to the index I. Now again check the new value, which means the new contribution, by just saying, okay, hey bro, are you the same as your new next person? If it is yes, just add your new contribution, my total color value. And ultimately for this particular query, I need to update my answer as answer of I equal to that particular total color. Same goes for I equal to n minus 1, where I will just go on and check for this value and my leftmost value and my just left value, which is I minus 1. What is your previous value? If it is not equal to 0, which means, okay, you both were having some color, so I can just decrease the contribution because I'm going to replace your ID. Now I will just replace your ID by that color, and I will just find, okay, what is your new contribution? New contribution, it can only be 1 or 0 because it is just I'm comparing with the left element. Now I'll just check, okay, hey, are you same with your left? If it is, then I will just add its contribution to my total color value, and I'll just update my query answer as it is. Now else part, which means when the elements are in mid, then what I did, but yeah, when the elements are in mid, then I will just check for both the left contribution and the right contribution. Then I will just check, okay, hey, firstly, please don't be 0, because contribution will only be affected when you are not 0. Cool. I will just remove that previous contribution part because it is going to be replaced. I will just replace that value with the color new value, and the new value will become the new contribution from the left and from the right. I'll just add the new contribution, and I will just ultimately add that to answer. And that is how we can just solve the answer for every query. When we actually saw, okay, the query was at the left, mid or right. We can also make this code pretty short by just adding those if-else condition in the mid. And also we can actually assume that, okay, the left is 0, right is actually, like, we can also have a minus 1 and n plus 1 index, n index, to actually make it short. But yeah, it was pretty easy, pretty fast to write, so I just wrote it like this, and that is how you will actually find the query for every answer. I hope that you guys got what we're gonna see in this problem. Before further ado, let's quickly read on the comments. And before that, you guys are just awesome. Just let's reach to 45 likes, because we're gonna reach to the last question. That was actually interesting one, like legit actually interesting one. I'll show you everything. I will just ask you also what you guys think of the approach of that problem, and then why that approach. Maybe it is the right approach, but maybe you're not able to find the test case on which it fails or something like that. I will help you out with it. So for that fourth question, just write down below what was your approach like, what you did, what you think of it should be, why you think it failed, or what do you think that what can be implemented, what cannot be, and so on and so forth. Before that, let's reach on to 45 likes. and just bang that thing in 45 likes. Let's, okay, no ads, skip the ads. Meanwhile, I'm reading the question, but your task is to actually write down the comments for that fourth question. Content discussion, please continue, Rakhna, please. Contest discussion, sorry. Bhai, could you please quickly tell YTL for you, Jagarat Gupta, if okay, make sure, correct, check on the go, correct, thanks bro, got it, okay, one key thing which really led me, okay, that is correct, damn it, I could have solved it, yeah, I was not able to solve that problem, solve the last problem, cool, no worries, Manmohan, we will actually solve that last problem, right, and now, no coder, lol for what? Maybe that clapping part. Yeah, that was. Please. Ha. That. Actions are just impeccable. Cool. Yes, two for what? Want to somehow use in order traversal. In order traversal. Okay. Why in order traversal, like what will happen? See, firstly, okay, I'm just marking your whatever you guys are thinking. Ready for the last question? Yeah, Vikram, we are actually going to the last question. Before that, can we actually reach on to 45 likes? If after reading the fourth question, you guys are getting the intuition and everything, we can reach 50-55 likes, but yeah. Meanwhile, let's reach 45 likes, but I'm not able to decide that key which node I have to increment. That was Ashish Pal, that was the best point which you said. Cannot decide which node to increment. People know that they have to increment to a particular number, but which node to increment? It was the big question. That was very good thing. Manmohan, I was thinking first I had to get the maximum root to leave path sum, then increment the value of the node. But yeah, as Ashish Pal said, which node? That was. But yeah, before that, as we have reached 45 likes, thank you. Let's reach to the question number 4. And if while going on to question 4, if you guys are liking it, then we can reach to 50 likes if you guys want. Yeah, let's quickly just go on to question number 4. Now, the problem says, let me quickly switch the tab, and here we are. The problem says that make the cost of paths equal in a binary tree. Make cost of paths equal in a binary tree. The problem says that you are having an integer n representing the number of nodes in a perfect binary tree. Mark my words, it's a perfect binary tree. Perfect binary tree is a tree where each node except the leaf node has exactly 2 children. Where every node has exactly two. Every node has exactly 2 children. Make this short. It is one thing which will help you. Not much, but it will help you. Consisting of nodes numbered from 1 to n. Okay, they have numbered the nodes from 1 to n. The root of the tree is node 1. Okay, it just starts from the node 1. It's the root of the tree, and each node I is in the tree has 2 children. For sure, as we said that every node has exactly 2 children, apart from the root node, which means it has, root node also has 2 children, but every node has 2 children except from the leaf nodes itself, because they are actually leaf. Now, each node I in the tree has 2 children, where the left child is 2 into I and the right child is 2 into I plus 1. If you have not watched the last lectures of our tree and graphs, we have actually told that for the node 1, its left is 2 and 3, its left is right is like this. Then we can just get the value. If this value is I, its value is 2 into I. Its value is 2 into I plus 1. So if we know the root node, we can actually go on to the child nodes by just doing the 2 into I of the root node and 2 into I plus 1 for the root node to get on the right child. It is very standard to actually, why it is used is to actually simulate or your array into a tree. Because in array you only have indexes. So basically to show your array as a tree, I will just mark some values, let's say as 1, 2, 3, 4, 5, 6. So it will just say this node has the left children as this and the right children as this. if the indexing is from 1 to 3. That is why it is used. Remember why it is used, that your indexing is, if you have the root node as I, your left child is 2 into I and right child is 2 into I plus 1. For the arrays, it's mostly used. But mark my words, it is when you start your root node from 1. If you start from 0, then it won't be valid. Then you have to just modify it a bit to actually get the left and the right child. But if it is starting from 1, then your left child is 2 into I, right child is 2 into I plus 1. Cool. Now you know one thing for sure. Each node in the tree also has a cost. Okay. Node has a number 1, 2, 3 up till n. Every node has a cost also, which is actually a 0 index, which means node 1, it will actually have a cost, but it will have at the index as 0. Node 2 will have a cost, but it will be at the index at 1. So basically, it is just saying that my nodes are numbered from 1 to n, and my cost is numbered from 0 to n minus 1. So it is just shifting one step back for our node to cost. We will see why we code, but it's no worries. Just imagine that for every node you have a value, just the cost of size n, where cost of I is the cost of the node I, right? Node I plus 1, yeah. Cost of I is the cost of the node I plus 1. As I said, for the node 2, the cost will be a cost of 1. Cost of 1. Because it is 0 index, so 1 index back. No worries. Return the minimum number of increments you need to make the cost of paths from root to leaf node equal. It is the main crux. Minimum number of increments you need to make the cost of paths from root to leaf as equal. The only thing you are concerned right now is the cost of the paths. From what? From root to leaf. And that you need to make what? Make them equal. Provided you need to do only minimum number of increments. That is it. Which means, let's say with this example, the cost right now is represented with this red circle. Forget for now the node values. Node values is just to map your node to actual the cost. So right now you only know, okay, these are the cost. Now, one thing for sure, which comes in a standard mind is, I need to make what? I am just marking. It is not the node number, it is the cost of that node, right? It is the cost of that node. Now, one thing for sure which comes in our mind is, what I need to do is, I need to, from root to leaf, I need to make every of those cost of paths from root to leaf as equal. So firstly, let's see. I'm just imagining right now. Firstly, let's see what is the cost of path from root to leaf. 1, 5, 7, 5, 6, 7, 8. Okay. Cost of path from root to leaf is 8. Cost of path from 5, 6, 7, 8, and 9. Right. It is 9. Cost of path is 2, 3, 3, 6. Cost of path is 2, 3, 4. 4, right, 4. Now, you need to change, you need to increment. Firstly, you can't change. You can only increment. You can only increment. Thus, one thing you for sure know, maximum is 9. Maximum is 9, which means others also you can make as 9 at max. But, the caveat is, which node to actually increase. You know for sure you have to increase your 9. One thing which looks very familiar to me is, or to you is, that it is 8. We can increase this number to 3. Okay, it will become a 9. Cool, no worries. Then I have to make this also as 9. Maybe one option which comes in people's mind is, how about I increase this number to 3? Which means I will just increase this number to 3. It will become add a 3 here. And I'll just maybe I add a 5 here, and it will become 9. Both will become a 9. So root to leaf has become 9. But you saw it is not the minimum number of increment, because ultimately you incremented plus 1 here, sorry, you incremented plus 1 here, plus 3 plus 5, 5, 8, 9. You did an increment of 9, while the problem says that you can do an increment of 6. So one thing for sure, that you can't increment blindly the leaf nodes. Okay, one thing went out of picture, that I can't increment the leaf nodes blindly. I have to find some other way. Cool. As we can easily see that to reach to an answer, what it did was that, see, as I was incrementing both by 5, let's say I was incrementing this by 3 and this by 5. How about I increment the root node by 3 only? So basically it will not increment by anyways, and it will just increment by 2. With this, what happened was 3 plus 2 plus 1, only 6 increments were needed, and you will just get, okay, I will just get my minimum number of increments. But you will just think, Aryan, how would I know that? Okay, I was just incrementing my leaf nodes because I thought that maybe I need to, firstly, just got one thing that, okay, I will just it is, see, right now we are just thinking what all possibilities we can think of. Maybe in between we think of something that we can actually reach to a solution. So right now we initially thought, okay, we have to make a 9, but for that, firstly we tried to increment all the leaf nodes, but it is more of a greedy thing, and greedy would want, maybe like incrementing only leaf nodes won't work. So we thought, okay, how about I just will move to the parents and will increment the parents itself. But still, only incrementing the parent, how about the tree is very big? How up, at what point you need to stop to actually go on to parent? How will you look at that? You can't, right? How about I just think of something else? Now, okay, I can't just have this option where I can just make everyone as 9 by just going on from bottom to top, and maybe just passing your increment value to the parent. I need to find the answer at every level, maybe, which means one thing which comes in people's mind is that, how about I just go on to every level and just try to make every level equal? Because ultimately what I want was that I want my sum from root to leaf as equal, right? My sum from root to leaf as equal. So how about I just make every level as equal, which means 1 equal, 5, 2, which means 2 is not equal, right? So just add a 3 here. Cool. Now what it will do is, to make this last line equal, what I will do is add, maximum is 3. So I just make everyone as maximum, because I can just increment operation. So I will just make it as plus 1 here and plus 2 here. Ultimately the number of increments done are 3 plus 2 plus 1, which is nothing but 6. What do you think? Is this method correct or not? Just comment below. Just comment right now below. Is the method of increasing, what I did was just thought, okay, what I want is from root to leaf, I just want my sum to be equal from root to leaf. So how about I just tried, and I also know I only can do one operation. I can just increment the values. So what I will do is I will just increment every of those node by that particular number. Is right now, just comment below that will this method work or not? Is this method correct or not? Before that, if you guys are liking it, just smash that like button. Let's reach on to 50 likes, because we're gonna see everything which a person can think while solving this problem, right? So we have taken its effect downwards as well. Yeah, we have taken just what my intuition was. Cool, but we will increment from root, leaf, level by level. We have take its effect downwards as well. Shashank is correct. Maybe like what he's about, like what he's trying to say is what I'm thinking of. I should have woken up early. His question seems doable. Make siblings equal and move upwards. We'll see. Aniket, we'll see. But yeah, right now, what was the issue in this problem? Maybe Shashank was able to say that was correct. We need to actually look on from root to leaf. Right now, I was just making my all the nodes as equal, which means I was making all the levels as equal. It was very much that I was just increasing every level to the maximum node. But it can be the case something like this, that if you just try to make your every level as equal, so you will just increment 4. But ultimately your main task was your root to leaf should be equal. And you will see your root to leaf 1 plus 2 plus 5, it's actually an 8. And 1 plus 6 plus 1 is actually an 8. So making your levels equal won't work. Now, what will work then? That is what we have seen earlier also. To actually make, see what your task was. Ultimately your task was to actually make, see what you saw. This node right here will only impact its child, right? So basically, if I just want anyhow that the sum from here, because see, think very small. Right now, you don't have the right part at all. You just only have to make your left part as equal. Let's go on to the above example to make it more clear. Just think very small. Just think, okay, you need to make your every of your root to leaf as equal. So imagine only the left part. Now, only for the left part, you need to make your left as equal. Now, the one option which comes in our mind is, okay, our parent is same. If they both are thinking with each other, if we both have to become the sum as equal, our parent is for sure same. So whatsoever sum will come from above will come same for us. If we both want to become equal, then I have to get incremented, because I have no other options, because my father, my grandfather, my everything is same. For both of us, everything is same. And the only operation we can have is increment. That is the reason I will just increment this thing by comparing it with its just parallel, because they both have same parents. So I'll just compare both of them and we'll try to make them equal. I will just compare both of them and we'll try to make them equal, which is plus 2. Because ultimately they both have the same parent. Just only think of up till that you have to make both of these same, not the entire tree, not the entire root to leaf. Just make sure that you have to make only both of these same. You have to make all of both of these same. The only impact, as from root to leaf, both are same. The only difference is right here. So what you have to do is just make them equal, which means make them equal to the maximum number. Maximum number is 3. So I will just make it equal to 3 also. For 3 making, for to make 1 as 3, I need to add a 2. That's the reason I just added a 2. Now it just became, okay, both have become a 3. Both have become a 3. Now, cool, both have become a 3. It also became 3, it also became 3. It also became 3, it also became 3. It can also be 4 or 4, no matter what. But it is one different. It is one different. Now, as it moves up, now it will just say both are 3. At the bottom both are 3. Currently it is 5. It is 2. Bottom both are 3. So right now it from this value up till the leaf, up till the whole down, the sum it can have is 5. It can have the sum as 8. It can have the sum as 5. And they both know for sure I have only one parent, which means up till here all these sum is above. So no matter what, we both have to become equal, because ultimately we just want to get the same flow downwards. So we both have to become equal, which means this 8 and 5 has to become equal. It can't reduce. So this 5 has to increase by how much? By 3. That is how you will just reach, okay, 8. So you saw increment 1 was done here, 1 was done here, and 1 was done here, which is for 2. That is how you will actually reach to your 6. Which means how we make sure that what was happening. We just thought, okay, for this particular child, for this child right here, I just imagined I only have to make both of these equal. Thus, I just added a 1. Because I wanted to make both of these equal, and both of these can be equal only when I just add a 1 right here. It is a condition. It is a worst condition. It's the most greediest condition I can think of, because the sum for sure up till here, is same for both of them. That is the reason how I will add it. Let's see this example very also. So basically here you will see it is both same. No worries. It will go up. and both are same. So the above thing which will go up is 5. I hope that you guys know how we go up in a DFS tree. If no, still I'll just show you how we go up in a recursion, how we go down in a recursion. In a recursion, there is a method we go down. In a recursion, there is a method we go up also. So as we go up, I will just give him the value. Okay, hey, your child has value so far as 5. Okay, it will just give that value. It will give 1. Now the current sum is nothing but 7. The current sum is nothing but 7. I don't have to change anything because the sum is same. I will just return those same value to up also, which means what happened right now was that I had these childs. So basically first I checked these. Individually. I checked both of them individually, both of them individually. So let's say it was some values. So I just made them all equal. Like x1 it is, both of them become equal to x2, both of them equal to x3, both of them equal to x4. I will just pass that x1 to above and just add that value to the current value. Let's say it is y1, it is y2, it is y3, it is y4. So I just add it. So it will become x1 plus y1, it will become x2 plus y2, it will become y2 plus x3 plus y3, it will become x4 plus y4. Now these both have to be same, right? So whatsoever maximum is there, I will just forward that up. Let's say the maximum was x1 plus y1, and let's say it is z1, it is z2. Let's say from here the maximum was, firstly I have to make them equal and then transfer the thing above, which is maximum, plus x, let's say maximum was x3 plus y3. Then I will just transfer this thing above. So basically at every step what I am doing is I am trying to make them equal. Both of those childs I'm trying to make them as equal, and then ultimately I'm just trying to give that value to my root. He will actually help me to find out, okay, if he and his next parent, maybe they all want to contribute anything or not. That is how you will do this problem. I hope that you guys got it, that what we are trying to do at every point. I'm just trying to check with my next, because this parent has these two child nodes, they will be just compared and will be tried to bring to the same value, which means maximum value out of it. So the contribution will be nothing but whichever is maximum minus whichever is minimum, or simple ABS of 2 minus 3, the cost of ABS, and then it will just transfer the maximum value to the its parent, and it will just compute the same thing again and again. That we can do by simple DFS operation. Let's see the code pretty quickly, but before that, can we reach on? If you guys have got it, then please write in the comment section, and for our well-being and enjoyment, can we reach to 50 likes right now? So basically, as you can see, firstly I will just call, as you can see, it's a recursive call, which means from the root. Firstly, can we reach to 50 likes? If you guys have got, if not, then just let me know that what you guys think is not understandable to you. I will explain that again, but I hope that that was very easy to understand. That what we need to do at a point of time is just make these two child as equal. If it is made equal, just okay, add those numbers what was required to make them equal and transfer that value to the root. Now it's a simple DFS call, which means from my root, I'm going to my child, then going to my child, then going to my child. The operations I am performing while returning back. I'm performing operations. You saw that, right? I will show that again, but wait a second. You were just going down. You were just going down until you reach the bottom. You just go down. As you reach down, then you were coming back up, and then you were performing the operations. The operations were starting from the leaf itself, not from the root. From root, first you went down, then while coming back you start the operation. Thus we'll do the same thing. we will just do this operation of DFS. DFS is just a recursion. It will handle everything by itself. Firstly, I just did that recursion. I started from the node 1 itself, node 1. And as we know, to go on to my child, I have to do a left child. To go on to the left child, I have to do a 2 into node. To go on to the right child, I have to do a 2 into node plus 1. Right? Cool. I can go to left child and right child. Okay. It will just entirely go. Base case is nothing but when it has to stop and return back. When your for sure node becomes more than n. Because as you saw in this problem, n was number of nodes. Right? So if the node which upcoming, let's say 8 comes, because see, after this 4, the next upcoming thing would have been 8 and 9. So 8 is more than this 7. So I can't go at 8, right? So it's the reason I just asked him, okay, if the node value coming up is more than my number n, please don't go it, please, just return a 0. Now let's see. Here is the answer, which is the final variable, which is the main, which is the minimum number of increments you need to make. It is the answer. We'll show how. But firstly, you saw what's happening. I am just going on to my left, right, and just entirely went on to my leaf nodes. While returning back, now I am performing my operation. So while going down, if you want to perform the operation, you perform here. While going down. But while coming up, if you perform this operation, then you make it here while coming up. If you are having an operation, and as we saw, I was performing my operations while I was coming up. That is the reason I will just say, okay, here ABS of left minus right. You saw why left minus right? I will show you again. The cost value was the left will return me the left cost, the right will return me the right cost. The left cost was 2. I'll just show you again. See, here it was same. Left minus right. Left will return you the left cost, right will return the right cost. We'll see what is it? It is returning. See, it is returning the cost itself. Right? So just make sure, okay, the cost will be being returned to us. But now how? It is what we'll do to actually say to increment in my answer. Okay, what is the impact it will have? It is 3, it is 2. The impact it needs to have right now, because it needs to make my left and right as equal. It needs to make. So whatsoever difference is there, I need to make them as equal. And it can happen that right is bigger, left is bigger, anything can happen. So I can just do a ABS of left minus right. It will actually make me give that, okay, increment I want in my values. Okay, let's firstly switch to our text. So basically, as you saw, I just incremented my left minus right. Left will give me the cost right now. Cost right now for left, because for the leaf nodes, it's actually the value itself. But yeah, right now for left, and it is right now for right. I will just do a subtraction to actually get that cost. Now, ultimately, while returning back, I can add my value. I'll for sure add, but I need to also add the maximum of my left and right. It is the cost right now for me, which means I show you the code back again, which means while returning up, returning up right now for this value, for this, let's say if I am returning from 5, then I will add my cost, which is cost of this node, right, plus the maximum from the left and right. Right, maximum was left and right is 2 and 3. Maximum is 3. I will just do a 8. So 8 is I need to make right now. It is, I will just do a, okay, the cost is this, left and right maximum is nothing but 3. So it is 5. It will return an 8, it will return a 5. And then it is left, it is right. It is new left, it is new right. Again, the same thing happened. Increment needed 8 minus 5. Increment needed 8 minus 5. Again, return the same thing. That is what is happening, that I'm returning cost plus what is maximum from left and right. I'm returning that. and as it reaches the leaf nodes, it will just return a 0 because leaf node has lower left and right. So maximum of left and right for leaf node, it's always 0. That is the reason for leaf node, it's only returning the cost of that node. The node minus 1, you remember why? Because your nodes are 1 based while your cost is 0 based. That is the reason you have the cost as node minus 1 plus max of left and right. And why this ABS? Because ultimately you need to find, okay, for these child nodes, which means for this left and the right child, what is the increment I want? I want this particular increment. That is ultimately your answer will increase one by one, and ultimately you will just return the answer. I hope that you guys liked it. Before we go on to the comments, can we please reach 55 likes? If you have guys got the code and the intuition and the logic, just smash that like button. I will be super happy because I'm thirsty right now. I'll just drink some water because I don't know, I should speak low, but I don't know why I keep on shouting. I speak way too much loudly. I don't know why, but yeah, can we just reach 55 likes and we'll just go through the comments. While I go on to the comments, meanwhile you have any queries, doubts, especially any real life problems, लड़की नहीं मिल रही, काम नहीं हो रहा, मार्क्स नहीं आ रहे, प्रोग्रामिंग नहीं हो रही, कुछ भी, any real life problems, anything we can discuss because the contest is ended for us. We have discussed entirely. We still have some time. We still can do some gupshup for let's say 5-6 minutes. But that was the end of this lecture. Let's quickly read the comments. But meanwhile, you can just write all your comments down. You might take me lightly, but legit, I have solution for every comment. But yeah, meanwhile, just जितना गिना दिए भैया, जितना गिना दिए सब, that's the sign of real digit. जितना गिना दिए सब, I don't know what that means. lol, English मत fade साले, not sure what that means. Fade. Can you tell me how I can improve myself? Okay, got it. But changing the parent node of the max path will change the max cost of the path. How will that work? Cool. That we showed that how it will work. Post order, got it, bro. In every contest I can solve first 3 questions, but I'm not able to solve the 4th question. It will just come incrementally. Sometimes you will be able to, sometimes you won't be able to. So that is no worries at all. Can you tell me how I can improve myself? It is just that we have to practice and think calmly. Firstly, just remove the idea from your mind that you can't solve. Just imagine, firstly train your mind that you can solve the 4th question. How you will train it? Just go and do some virtual contests and just for 2-3 contests solve 4th question by yourself as you just solve. Because see, it is very much into our minds which triggers us to say we can solve it, we cannot solve it. If your mind says it's easy, you can solve it, so no matter what you can solve it. Usually it happens. Maybe you have been solving your question 1, 2, 3 for so long. That's the reason that your mind easily says, okay, it's question 1. No matter if you just have a wrong answer also, still you will think, okay, you can solve it because you know you have been solving it for years. So it's the reason that we have to trick our brains in thinking that we can solve the 4th question, so that actually we can think, because it's not always necessary that we will actually be able to solve it, but our brain will apply more power to that 4th question, considering it will just imagine, okay, hey, what's his name? Hey Manmohan, you can actually solve it because you have solved the 4th question in past contests also. So maybe you can solve it question. Just try a few minutes also. That is how you will actually be able to actually see it. It won't work in a day. It's just that how you fake confidence. Just fake it until you make it. Just fake your mind, and your mind is very smart. It can't be faken if it's a word. It can't get faken if actually you are just saying, okay, hey, you can solve the 4th question. You actually have to trick him by actually solving the 4th question multiple times, by not actual contest but virtual, or actually solving the 4th questions by yourself, so that he can actually get tricked that okay, he knows that he have been solving the fourth question for a few times. Now he can solve the fourth question. That is it actually is a psychology concept, but it works in many areas of life, in tricking yourselves also and others also, entirely. English mat fade. What is fade? I don't know. IG practice is all it takes. Absolving is necessary too. Correct. Lol, Isha Sheri, Sheikh, Bhai OP in the chat. Cool. Yeah, I was so easy, but didn't get in the contest. Yeah, that was. Thank God, Aryan. Thanks, Jina, Gina, this sub. Or at line number 16, why are we taking diff of left and right? Why not diff of cost of that node? See, the cost is automatically being returned by this left and right. This left is nothing but a DFS. This DFS is returning me the cost itself. It's not the node number. It is the DFS, and this DFS is returning me the cost itself. That is the reason I am returning the cost and not the node number. And you say, okay, what is for the last root leaf node, what is the left and right? For the leaf node, the left and right will return itself a 0, because ultimately for the leaf node, which means node, the 2 into node will actually surpass this n. If I am visible, yep, I am. So it will surpass this n. That is the reason both left and right for the leaf nodes will return a 0. That is the reason for the leaf nodes, you will just return the cost of the leaf nodes. That is why we are actually grabbing the ABS of left minus right, because it's actually the cost ultimately. जितना आपने बोला उतना सब प्रॉब्लम है GF and all. See, considering in which year are you, Ashish Pal? See, just that, see, that I'm not saying to actually go into that part, but just, see, that is very generic ki we all want to have, a girl should come in the life and we should have enjoy and all that stuff, but it's not necessary that you can, firstly, just try to make friends. I'm not saying to go in the friend zone, but actually just try to make multiple friends and just try to maybe increase the approachability and that game which actually can help you get to interact more. For sure, if right now not getting a GFC, it's actually not that much more of ki, it's not a GF, it's not a BF thing, it's more of how we interact with other folks, girls or boys, that how we can actually get it done. For boys, it's much harder because you have to do the most effort, but still, it is that we have to get an interaction game, speaking game, like maintaining the vibe game strong, maintaining that fun, chill vibes while actually interacting, so that actually someone can actually gaze your attention and actually just keep on with you. It's actually like, see, if I can speak in Hindi for sure, I can actually like speak on those stuff, but yeah, for sure we'll make some video on that part later, but it's mostly on the interaction of maybe we have to improve on our हम बात कैसे करते हैं, हम कितना एनर्जी ला रहे हैं उस कन्वर्सेशन में, and it should not be very standard generic kind of a roasting, praising mixture of all those stuff. Very chill. How you talk with your guys, we should talk with the girls too, and especially it doesn't happen as we see, we like, it's very standard that we try to put a girl at pedestal, it is what we say, yeah, and then it just goes down ways. We have to just remove that part so that we actually start talking to them, not in a very way, not that sense, be more casual, not ekdam bilkul Merathi types. Like Merathi is my just kind of how people in my local used to speak, so that is how I referred. Problem जितना आप बोल रहे हो उतना सब है. I am a QA engineer and want to transition to dev. Firstly, let's quickly switch on. before that, if you guys are still staying 19 folks, please can we have that like button pressed. Let's see, 60 likes. But yeah, before that, I'm a QA engineer and want to transition to dev. I have been solving DSA on a daily basis. What should I do to get calls for dev roles? A suggestion for me. That is actually see, to get the calls, if your profile is not that visible on LinkedIn, which means if you have just a very good resume or something, it will be easy to get the calls. Recruiters for sure reach out to you by yourself. But if it is not, then that's a very standard trick which I used to use to tell other people that what they can do is just filter out the companies, and how to actually filter out that, okay, I want to apply on all these companies. The list of companies is already, we have made a video for the projects, 10 plus projects, in which I've actually shown you the exact list of companies. Again, maybe I can just show you, or you can just go and see that video. Wait, I'll just show the video to you guys. In that video itself, all the list of companies are actually mentioned. What all list of companies are there, and let me quickly switch that screen. So if you guys can just, oh, it's the exact same. If you guys can just see, it is the video which is I was referring to. So basically in this, you can easily see that we have all the list of companies. So for sure, just go, and now you know the company name. And you know the company name, you can just go, one option is to go on their career page and just see what all openings are there. Another option is to actually go on LinkedIn, and from that go on to work. In that, there will be options of how many people are actually viewing that or have posted in their work profile for that particular company. Let's say D Show. In the D Show's company page of LinkedIn, there will be a work section where the postings will be there, and also from in that posting it will be shown, okay, the recruiter right here posted this posting. So you can just send a connection request to that recruiter from that LinkedIn job post. How will you search for the job post? You know the company name, just write the company name on the LinkedIn search bar. That search bar will open. Just go on to that company name. After that, as you go into that company name, next you go on to, okay, that work, what all openings are there. As you go on to that work, what all openings are there, that opening will be there, and also the recruiter which mentioned that opening will also be mentioned. Just send a connection request or a cold email or just a message to that recruiter saying out your profile, and there's a high chance via that you can get a call. But just one option is you can just apply via referral, but I've seen straight away approaching route to recruiters is much more beneficial than applying via referral. But if you have a good referral connection also, then it's actually good, but it actually wastes a bit time. If you can actually ask a recruiter, ask both ways, ask for a referral also from your fellow folks on LinkedIn and all that stuff, and also just go and directly contact the recruiter itself. नेक्स्ट भैया वेब डेवलपमेंट में थोड़ा गाइड करो, गोंदी टेक्नोलॉजी सही होगी जिसपे मैं टाइम इन्वेस्ट करूं, भैया थोड़ा डेवलपमेंट भी गाइड करो. इन वेब डेवलपमेंट द बेस्ट पार्ट इज टू लर्न बैक एंड and front end, like just learn JavaScript, Node.js, how to connect a DB. Web development is actually a very in demand and very scalable skill, right? It is one thing. When I was searching, when I was making the video for all the job postings, I was actually searching on the entire job listings, and I saw WebD was one of these, especially front end and back end. Like specifically, it was mentioned you want to apply for the front end part or the back end part, but it was one of the most demanding skill right now. So for that, just start with the WebD. Just learn the basic front end, HTML, CSS, JavaScript. Just learn the basic back end, Node.js and all that stuff. Just try to connect with a DB. Just learn maybe MongoDB and stuff, and just make a project. See, it just says, okay, I'm just saying, okay, make this, make that, learn this, learn that. It will take a time. WebD is actually very big thing. To actually get good at maybe front or back end, it actually will take time. So WebD, although I can say easily that machine learning AI has a power, has a growth, you should just do machine learning and AI. But in my entire college, I did AI machine learning. I did only AI machine learning. I did Android AI. I did initially in my first year, I did Android. Then later years, I did machine learning, and then deep learning, and then that's it. I entirely just did machine learning, deep learning, and Android. A little bit of here and there WebD for projects and all, but that's it. But I would not see a very much big outcome of that ML and AI. It's just that standard algorithms. Maybe you get smarter algorithms and all that stuff, but project wise, industry wise, I don't think right now there's a big scope in, let's say, coming 2-3 years. Although there's a hype of AI, chat, GPT, GPT-4, 5, so on and so forth, but still, as a tech for industry right now, you can't just have a simple knowledge of ML and AI algorithms and can just make something very great. You can just write research papers, amazing research papers. You can just optimize your algorithms and stuff. But still, I highly recommend start off with WebD as a side interest. As a side interest, what you can do is just try to learn ML, AI, algorithms, basic algorithms, regression, then maybe like NLP, all that stuff. But start with WebD as of starting. But as we go on, that we can just switch on to ML and AI. It's actually very interesting, very interesting. The scope and the fun you can have with ML and AI now, it's immense. I just love that part still. Cool. I just thought, Bhaiya, we need your help in development also nowadays. Development, cool. हाँ, okay. विशाल कुमार got it. Thanks. मजाक किया आपसे जैसा आप हमसे कर रहे हो. प्रॉब्लम जितना आपने बोला उतना सब प्रॉब्लम है जी. अच्छा, okay, no worries. Due to regression, dev roles and more than SD को company expecting to have decent dev experience from us. See, a company will expect anything and everything, but for sure, if you don't have the dev experience right now, still you will get the role, provided you have skills. Provided they may try to offer you less pay, but you will just play gamble with them. Just get the offer. Maybe it's less pay right now. Maybe you are expecting, let's say, 80 lakhs. You get, let's say, 45 lakhs or 50 lakhs. You will just try to gamble that same stuff with other company, with other interviewer. That is how you can increase your offer chances. So it will for sure happen that a company will say, okay, you don't have the experience right now, we'll pay you less. But provided you have worked on that tech, they will not say that we will not hire you. How to show that you have worked? Projects. Just show your projects, what you have made, what you have done. It will actually showcase. Provided you have no experience in industry, in that field, but you have projects, which shows that you have worked on that. That is how, and see, for sure, there's a trade-off that, okay, you have projects, but you have no experience. So for sure, they will try to lowball you and say, okay, we'll pay you less. But you actually can get a higher pay by just try to trade off that pay with other company. It's no harm. Like, every company just is working for their own profit. Just grab that offer letter, show that offer letter to other company, and just grab that. That is all how we can actually get increment in our pay from 3, 5, 6, 7, 10, 20, 30. It is how we increment. First skills, then just trade off with the other companies. Please make sure that parallelly you are incrementing your skills. It's entirely the game of skills and also how you showcase it. To showcase it, the skills part, we have projects. To show the intelligence part, we have this programming contest and all that stuff. मजाक किया आपसे, सीरियस हो गए आर्यन भाई तो ha. No worries. That was all. It was actually It's actually a big stuff. See, I'm not being serious, but when the things make you happy from all these sides, maybe you are very much in college, very happy and all that stuff. But I've seen many folks in industry right now, they are super depressed because of all this stuff. So yeah, maybe we should start working on that from college itself. It's just for a hint for you guys. Node is more than n by 2. Node is more than n by 2. Correct it. Node is more than n by 2. I'm just passing my node as 2 into node. So whatsoever come to me will become as 2 into node. So as the node which is coming as 2 into node itself will become more than a, then I will return a 0. That is all. I hope that there is no question. Before leaving, there are some folks on our stream. It will be very helpful if you guys can please like it. And yeah, we are actually pretty much late. Cool. See you guys. Bye-bye. Tata. Goodbye. Thank you so much for joining. Shishank, Vishal, 404 not found. Abhilash, Ashish, Aniket, Isha, Manmohan, Vaibhav, Faisal, Shishank has done, and MS Darshan was there but is not here right now. No worries. Noob Coder, Manmohan, Jagrat, not sure. Please pronounce how I'm pronouncing here that. Maybe I'm wrong. Ashish Pal, Divyansh, Jagrat, Mani, Aniruddha, and Ajit, and so on and so forth. Shashinder. Thank you all so much for joining. That was all. See you guys next time. Goodbye. Take care.